friends, today we'll see different Cromptons and Greaves make relay. One is motor control relay, then feeder control relay, and like this category we are having here MC112. This is the motor production relay, and similar to that feeder control relay will come FC112. If you see here, this is one more model relay. This is CGI 14C. This is overcurrent and arc fault relay. So like that, one more model is this one. This is CGB 24C. Here it is under voltage, over voltage, and neutral displacement we can protection we can give it. This is CGB 24C. Nowadays, one more new model relay coming, that is MG112X2G. That is the new version for MC112. So this is also motor protection relay. This is CGI 14C overcurrent relay. In this relay we can configure 2 overcurrent, 1 arc fault, 1 sensitive arc fault, or 3 overcurrent, 1 arc fault we can configure it. As per our requirement we have to give the order. This is CG make, and similar way one more model will come CGI 14N. So in that both are same type of relay, only that fault record here in 14C 10 records it will be stored, whereas in CGI 14N only 5 records will be stored. So in this relay we can see here PF means overcurrent protections. It has 2 stages. First is this stage 1, second is stage 2. Similar way arc fault also 2 stages. This is stage 1 and this is stage 2. And this is sensitive arc fault. That enable, disable, everything configuration we can do it. This password is 002. So in the starting itself we can see here, I am clicking right, if you press down here 002. In this once you enter that password, then it will be enabling that changes for half an hour. So that the password will be active for half an hour. Within half an hour we have to change whatever required, we have to do it. So like that enable, this is the measurement section. So this is the power, this is PF means overcurrent. So overcurrent stage 1 is like this. This is IDMT overcurrent. So this is 78% taken. So this is corp, different type of cores will be there, SI3 or normal inverse or standard inverse or long term inverse we can take it. So different curve, if any changes required, like putting a enter here, select the curve, we can change SI1, very inverse, extremely inverse, long time inverse, definite time, like that we can take it. So this is SI3 kept by default, that we can change it as per our, it is the time multiplier settings 0.25 there, then delay also 2 seconds given here. Like that stage 2 also we can, this is instantaneous actually, 400% given, that also delay is there, nearly 0.02 seconds. So that 20 milliseconds delay is there, that also we can change it. If it is required instantaneous, we have to make it 0. Like that arc fault also having settings. Stage 1 that is IDMT type, and stage 2 it is instantaneous type. And one more is your test trip one is there. So whether through relay it is trip contact activating or not, for checking that purpose on, this is called trip test enable. If you press down here, you can see trip test is enabled. So it is on conditions. Just pressing escape, it will be reset. This is one more model CGB 24C. This is a voltage relay. In this relay we can see over voltage, under voltage, and the neutral displacement, neutral voltage, that protection is there. So here you can see, if you go down here, one CGB 24C protection type, if you press right click here, you can see here 3 face to face and 3 V0. We can change it if required. Actually we have to give the password same 002. So here protection is there, that I can change it. So here you can see here 3 face to face and NDR. This is the neutral displacement. If not required, only 3 face to face will be there like this. So 3 protections, 1 face to face, only voltage protection. If you consider V0 on the neutral voltage, then V0 will be there, otherwise neutral displacement. This is NDR. So this relay and having this as under voltage setting is there. This is having under voltage setting, and this is under over voltage settings. Over voltage settings, this is 115% given, and definite time. As per our requirement, we can give it. This we can change it. In same way, under voltage also it will be there. Under voltage settings, if you press right again down, then you can see the 80% is there. So 80% under voltage and 110% or 115% over voltage is there. In NDR setting, generally we are giving 3 to 20 volts we are giving NDR settings. That we can see here to go down this protection T, and if you go down here 15 volt is there by default, that we can change it. So these are the only 3, particularly over voltage, under voltage and NDR protection is there in this particular relay CGB24C. So before we start this communication with the relay, let us see a small comparison of this relay with the other company relay. This is CGMG112. It will provide nearly 15 different type of motor protections, from overcurrent arc fault to under voltage, over voltage, negative phase sequence current protections, negative phase sequence over voltage protection, like that. This approximate price is 55,000 rupees. Whereas in ABB make REM610 or REM611, that also provide the similar range of protections, but the cost will be 80,000 rupees. Whereas Schneider make MICOM P220 or P225 relay is there, that also provide the similar range of protection, but the cost will be nearly 95,000 rupees. One more type of relay, Ciprotech 7SK80, that will provide some additional protections compared to other make relay, but the cost will be nearly 2 lakhs rupees. So these are all approximate price. It depends on our quantity we are ordering and the final negotiations. So we'll start communicating with the relay. So I have connected my laptop with the relay using that USB to UART cable, just like similar to printer cable, and the software is on edges software given by CG. So once you open, this is the initial screen. It will come, it will give a serial connection options, Ethernet and QTT or offline type. Suppose you are already having a setting files, you can open it with the offline mode. You can check the settings. Presently already I have connected the relay with the laptop, so with the cable. So just click the connect. No need to check any settings, nothing is required. Automatically it will detect the COM port and it will connect the baud rate, everything, but default it will take. So it is in the process of connecting to the relay. So it will download all the settings from the relay to the laptop. So it is saying read and refresh from the relay completed. See the status product. So all the settings, everything is now downloaded to the laptop. Now we can see all the settings here. Just by clicking settings here, you can see here. Initially the configuration will be like your CT ratio, PT ratio, and if sensitive arc fault we are using that CT ratio, everything we can define here, just like it is that CT ratio primary 50 and secondary 1, so 50 by 1 amps the main CT ratio, and for arc fault 100 by 1 amps. Like that primary PT also 6.6 kV by 110, like that frequency 50 Hz. All these things settings we can configure it. Here drop down is there. If any setting up and down required, you can do it. Simply just suppose I want to make it to 100 per 1, simply write modify to do write successful, so it will become 100 per 1. So like that changing any settings, it is very easy. So these are all configuration settings. In the measurement section, it will show the relay is taken into service, then it will show the current, three-phase current, voltage, line to line voltage, line to neutral, then secondary currents, current voltage angles, phase angles, and like that lot of other parameters are there. If you come to the last section of this measurement parts, you will see system date and time. That means the relay date and time, if it is not updated, just simply clicking here update the system date and time, automatically it will update the system date and time. So 13/2 and the 1925, it will exactly take the system date and time and update it. This is a very useful keeping the relay updated date and time, because whenever there is a fault happening, exact date and time knowing means we can analyze the fault. Now we come to this overcurrent or any other protections. Suppose overcurrent, one option will be settings, one option will be binary input and output. Suppose I click the double clicking that settings. You can see here this is the overcurrent settings. This relay will provide nearly 6 stages of protections. So first stage 1, stage 2, like that, stage 2, stage 3, stage 4, stage 5 and stage 6. Generally we are using first stage as the IDMT overcurrent protection, and the second stage generally we are using for the instantaneous overcurrent protections. 51 and 50. IDMT means 51 and instantaneous is the 50. And lastly you will find, suppose its settings which are enabled, that will come in the green color. Suppose first stage is disable, I just want to make it enable, I just click enable here and write modified. You will see that also coming in the green color. That means these are all settings are enabled, remaining white colors are disable settings. Like that if I again make it to disable, I can make it to disable, write modified and write successful. So enabling and disabling very easy here in this softwares. And suppose number of changes I am making, then you click write all, then all this number of changes automatically it will be writing into the relay. Here different core will be there, that like SI3, SI1, normal inverse, very inverse, extremely inverse, long time inverse, like different IE core will be there, that you can select. So generally CG make relay utilizing SI3. SI3 is nothing but normal inverse curve. So and the time TMS multipliers settings, as per our requirement we have to set it. So this is IDMT overcurrent. Next is instantaneous, 700% given, definite time, or you can say curve also you can use, or zero putting means automatically whatever time required you can give it. Like that, last section you can see what are the LEDs here. So these settings we can see in the last part is the LED configuration, that which LED required for the particular protection trip or pickup. T means T trip and P means pickup. These two we can configure the different LEDs. So first actually this relay having 16 LEDs. Out of that, first 5 LEDs are reserved. First one is power on off utilizing alarm, anything is there, that is second LED. Trip indication means third one. Fourth one error is there. fifth one is the internal use of this relay. So remaining 6 to 16 we can configure it. Any as per our requirement we can configure it. Similar way, like we want to select the LED number, then just click the right modify, automatically it will write. Like that, if you come down to binary input and binary output sections, you can see here this relay having 4 binary input and 8 binary output. Here you can see all the green colors are binary output is configured in this relay. So binary output 3, suppose this is overcurrent stage 1 trip. So here on off you can do it as per our requirement, you can do it, you can modify it. Next, like to come here, all green colors are configured, which are white color are not configured, like that. So this is related to overcurrent. Similar to arc fault also, you will find settings will be there, then binary input output, that settings will be there, or that configuration pages will come. Now if you come down here little bit, you can see your binary output and input settings will be there. The LED settings, if you want to see here, third one, you will see whatever the LEDs we have configured in this relay, for which protection, which LED is configured in a single page, you can see here. So we have taken all the trip indication only. We have not given any, we have not utilized any LED for the pickup or the all running stages. So this is pickup for P for pickup, but we have not utilized the single LED. So LED 9 for the overrun stage 1, like that. LED 13 for the under voltage stage 1 trip, like that. Whatever the LED is required as per our requirement, we can change it and we can configure it. Next is the binary output. If you want to see in a single page, that also we can see here. So you can see here the binary outputs for the stall protection trip. You can see here binary output 5 is configured. For the phase reversal trip, it is also given binary output 5, like that. Suppose it is binary output 3 is overcurrent stage 1. So as per our requirement, we can configure it. All green colors are already configured in the relay. So just like similar to that on off, we can change it, like you can make it on or you can make it off, and write modified, automatically it will write. One more is self reset and hand reset. Difference is that whenever fault is there, that binary output in the pickup stages, so automatically whenever fault is cleared, then that binary output will be reset automatically. But generally, if we want to know which fault has happened during the disturbance time, then in that in hand reset type, whereas that binary output we are giving as self reset type. So hand reset means just we have to press that escape key, then that LED will be resetted. This is the difference, hand reset and self reset. Next, if you see here, logic is there. So suppose additional logic if we want to build here, that also option given in this relay. So this is the logic building pages. So we can build the logic like I've taken an AND gate, suppose, and suppose I will take any two parameter like overcurrent stage 1 and overcurrent stage 2. Suppose if the two overcurrent stage 1 and stage 2 tripping, then after I will give a timer here. This is an example. I will take a timer here. Suppose this is, I will take as a on delay timer, and timing is 2 seconds given. Then the output I will take as a binary output, or LED or output relay we can take it. Suppose output carrier, and that number is 8. I will take it 8, and if I connect it, then this is the logic. Like if stage 1 and stage 2 both stages trip, that is the AND gate. So if both the inputs are high, output will be high. So after some delay, 2 seconds delay, the output contact will be pick up. So this binary output 8. So like that, very simple way we can build a logic. But logics are additional that we can build it and we can write into the relay. Here built is there. If you build the logic, it will check each and every parameter, and finally we have to write the relay. Right option is there. So now we want to save all the settings. Saving settings having 3 different, 2 particular save as, and Excel to export to Excel is there. So saving having 2 options. One is to Excel file and like export to Excel. Suppose settings, exported successfully. If you look into the desktop, you will find setting file is there in the Excel format that you can study anytime, any systems. Is the benefit. Configuration each and everything, CT ratio, PT ratio, any other settings, thermal overload settings, self LED number, protection percentage, everything enable or disable, everything will come here. This is very helpful. One more way of saving is that save option is there. Suppose I want to save here with the name of PA3B. Saving your desktop, you will find this also save the settings. But this is useful 2 way. One is, suppose you want to see the settings file in the offline mode, that setting is useful. Second is, if suppose we want to write the settings to other similar type of relay, there is to the other relay also. So in that case, that is useful. Using that relay we can. Now suppose motor prediction relay, file name is PA3A. Suppose already I have kept one file. Suppose that PA3B. Just already I extracted like that file. So I am keeping open. So here you can see file open options, open setting files, any logic, design, anything, it will open also. File opened successfully now. Now one setting file I kept here and I just open in the software. Now suppose this setting file I want to write in the present connected relay. Just here you can see, if you click setting here, downside you can see read and write all. One option is there. So suppose logical nothing is there, no need to click this one. Test injection, initial time of testing time, if anything settings is there, that also not required. Logic and setting file name, these two if you want to write, just click write all. Now we will see that our desktop or the laptop, whatever the settings we opened, that is uploading to the relay. Now whenever that protection, any error will come or any writing error will come, that will come in the red color, that we have to analyze. So the finally message will come, write to relay completed. So now this settings, everything is now written into the relay. Suppose this is the overcurrent settings. If anything is there changes, you can change it. So like that, number of relay, same settings, if it is there, we can utilize it. So this is all about CG make motor protection relay MG112 communications, then settings, then binary input, binary output, LEDs, and finally how to save the data, save the settings, and finally how to upload any setting file to the relay. Thank you so much.